What's up, everyone? Welcome back. Patrick here. Moving on to the next example in the exponential functions unit test for grade 11 functions. Another thinking problem. This one's going to be pretty tricky. It was sent to me by a student. And so what we are told here is that for each 2-centimeter piece of glass put in front of a light source, the intensity of the light reduces by 4.3%. And so given that information, we have to answer two questions. Part A, by how much is the light intensity reduced if there is 10 centimeters of glass in front of the light source? And then part B, how many pieces of glass are required to reduce the light intensity by 70.8%? Okay, so there is lots going on here. And so before we get into talking about this, let me just kind of maybe visually show what's going on. So we got this light source, right? It's emitting some light here. And if there's no glass in front, well, the intensity is going to start at 100%. So that's actually going to be our initial value. And then what they're saying is that, okay, if we put a 2-centimeter piece of glass in front, right, this is 2 centimeters here, the light intensity is going to be reduced by 4.3%. Okay, so 4.3% though, not in a linear way, but 4.3% of what the light intensity is before it. So what's 4.3% of 100%? Well, it's just 4.3, right? Because 100 is just a nice number, right? So 4.3% of 100% is just 4.3%. So what we're going to end up with now is a light source that has an intensity of 95.7% after we put one piece of glass on it. Now, if we put the next piece of glass in front, right? So the next 2-centimeter piece of glass in front, it's going to reduce the light intensity by 4.3%, but not in a linear way, as I mentioned. You're not just going to subtract 4.3% from the 95.7%. Now the light is 95.7% intense. You're going to subtract 4.3% of that amount from it. Okay, so it's basically decaying exponentially, right? You keep subtracting 4.3% from the value before, right? So it's not like you're just subtracting 4.3 in a linear way. It's an exponential decaying function. So that's the first thing to recognize. Now, what we have to do is we have to create first a function that's going to relate the light intensity that we have versus the amount of glass that we put in front of the light. And so there's actually multiple ways to create this equation, and it really depends on what we're going to let the x value be. So I'm going to first let the x value be the number of pieces of 2-centimeter glass. Okay, the number of pieces of 2-centimeter glass. It doesn't represent the total amount of centimeters of glass. It represents the number of pieces, and each piece has 2 centimeters. So that's an important distinction to make, right? So if we let x be that variable, then our equation is going to be basically the initial amount, which is 100%. And what's happening is that it's decaying by 4.3% each time. So we would subtract 0.043. We got to convert the 4.3% to decimals. And it's basically decaying by 4.3% for every piece of glass that we put in front. So it would just be to the power of x, like that. All right, so that's probably the function that I'm going to use throughout the rest of this question. And I'm going to let x be the number of pieces of 2-centimeter glass. Another way you could set this up, though, is you could let x be the number, or let's say the total centimeters of glass. Now, I personally wouldn't go about it this way, because we're told that the 4.3% is basically, that's the reduction in the light intensity for every piece of glass. So it's just super easy to have a single exponent there, x, and let x be the number of pieces of glass. If you put the total centimeters of glass, then your function is going to change to this part's going to be the same, but the exponent's going to be x over 2, like that. Okay, now why is that? Well, let's say we have 6 centimeters of glass in front. Well, if each piece is 2 centimeters, that means we're going to have 3 pieces in front. So you could put the 6 here for x, and you'd end up with an exponent of 3, or you could realize that 6 centimeters of glass means that there's 3 pieces of glass, and if we let x be the number of pieces, you could just put 3 directly into that function. Okay, so it really depends if you want to make x be the total centimeters of glass. If you do that, you're going to have to divide this by 2, because this exponent has to represent, this whole exponent has to represent the number of pieces ultimately. So whether you want to just do it right away, or whether you want to input the total centimeters, you're going to have to divide that by 2 to get the total pieces in that exponent. So 2 different functions you could create. I'm going to go with this one. I think it's the better option, but if you didn't want to go with making x the total centimeters of glass that's in front of the light, just make sure that you're going to divide that exponent by 2, or that x value by 2, because that total exponent always has to represent the number of pieces, because we know that each piece is reducing the light intensity by 4.3%. And since we put the r as negative 0.043, well, that exponent has to be the thing that's making the decay happen. And the thing that's making the decay happen is the number of pieces of glass. Then each piece of glass is reducing it by 4.3%. So the exponent ultimately has to be the number of pieces. Okay, but again, I'm going to go with this one. I'm going to let x be the number of pieces of glass. Yo, what's up? Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number 1, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit that have video solutions. Number 2, if you feel like you need tutoring at any point, hit me up. I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. Now, what we could do with this equation is we could actually simplify this bracket 1 minus 0.043. That's going to be 0.957 to the power of x, like that. Okay, so that's the equation I'm going to use for parts A and B. Now, in part A, they're saying by how much is the light intensity reduced if there is 10 centimeters of glass in front of the light source. So you got to be careful here. They didn't tell us the number of pieces of 2 centimeters glass, which is what the x represents. They told us the total amount of the glass, which is 10 centimeters. So we have to actually figure out what is the number of pieces going to be, because that's the number we're going to have to input here. So if there's 10 centimeters of glass in total, and then every piece has 2 centimeters, right? 2 centimeters per piece. Well, that means there's going to be 5 pieces, like that. So that is what we would input for x in part A. Okay, so we would do f equals 100.957 to the power of 5. That's going to be 100.803, right? You do the exponent first. and then that's going to be 80.3. So that's going to be the final amount, or the intensity of the light source, if 5 pieces of glass are put in front. Now you got to be careful with this question. They're saying by how much was the light intensity reduced. They're not asking what's the new light intensity. So we started with 100. Okay, we put 5 pieces of glass in front, and now the light intensity is 80.3%. So by how much was the light intensity reduced? Well, it would be 100 minus 80.3. So 19.7%. So that's the answer to part A. So you got to read these carefully, right? They're not asking what's the intensity of the light source now. They're saying by how much was it reduced? It was reduced by 19.7% from 100 to 80.3. Now in part C, what they're asking is how many pieces of glass are required to reduce the light intensity by 70.8%. So again, you got to be careful here. You don't plug in 70.8 for the F value, the final value. So let's think about this. You're starting at 100. You're reducing the light intensity by 70.8. So now your final light intensity is going to be 29.2%, right? So 29.2 is what you plug in for F. This is how much it decayed by. This is the final amount right here. So we have to find out when or how many pieces of glass is going to be required. We're going to solve for X to go from light source at 100% to it having an intensity of 29.2%, or it reducing the light intensity by 70.8. So you got to read these super carefully. And now what we do is we just solve for X. So what we want to do, we want to divide both sides by 100. So this would give us 0.292. And then this is going to be 0.957 to the power of X, like that. Now, if you remember, I've mentioned this a bunch of times. If you want to solve for an X variable in an equation like this, so if we have like M equals N to the power of X, and we want to isolate for this X, what we would do is we would take the log of this and divide it by the log of whatever the base is. So notice in this case, the M, it's like this 0.92. The N is the 0.97. So if we want to get the X by itself, X would basically be log of 0.292 divided by log of 0.957. And when you do that in your calculator, you would get 28. All right, so it takes 28 pieces of 2 centimeter glass for the light intensity to be reduced by 70.8%, or to be reduced to an amount of 29.2%. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.